Okay, so the question we're going to approach today is a titration question. I'm going to do a walkthrough. So this question is saying 10 centimeters cubed of a solution of potassium hydroxide was titrated with 0.1 mole per decimeters cubed solution of hydrochloric acid. 13.5 centimeters cubed of the acid was required for neutralization. Calculate the concentration of the potassium hydroxide solution. You get a lot of these questions nowadays, and it's important that we address them using a very simple method. And for this, we're going to use a formula triangle, which I have here. N represents the number of moles, C represents concentration in moles per decimeters cubed, and V represents volume in decimeters cubed as well. I've got a little conversion chart there which shows the conversion between centimeters cubed and decimeters cubed, where in order to get from centimeters cubed to decimeters cubed, you divide by 1000, and when you try and get from decimeters cubed to centimeters cubed, you multiply it by 1000. Okay, so the first step we need to do is write a balanced equation. So you can see this equation reads as potassium hydroxide plus hydrochloric acid gives us potassium chloride plus water. And so that's an alkali plus an acid gives us a salt plus water. You can see it's balanced all the way through, which is very important. We'll see why later on. Okay, the next thing we've got to do is to actually draw a table. Okay, so this table will help us to answer the question. It's a very simple format. So underneath the alkali, we're going to write alkali. And underneath the acid, we'll write acid. And we'll list out N, C, and V just to help us fill in the parts of the question that we actually have and help us actually calculate what's missing. So we want to find the concentration of the alkali. That's clear from the question. Now we fill in what we do have. So from the question, we have 10 centimeters cubed. So that is the volume of potassium hydroxide. So we need to convert that into decimeters cubed, and we do that by dividing by 1000, which will give us 0.01 decimeters cubed. Then what else do we have? We don't have the number of moles of alkali, but for the acid we do have the concentration of the acid, which is 0.10 moles per decimeters cubed, and also the volume, which once again we've got to convert from centimeters cubed to decimeters cubed. So 13.5 centimeters cubed to decimeters cubed. There we've got to make sure we divide by 1000 again, and that would give us 0.0135. Okay, from this we can actually calculate the number of moles of acid using the formula triangle. So number of moles equals concentration times volume, and so if I multiply 0.1 by 0.0135, that will give us our answer. (1.35 times 10 to the power of -3). Okay, so there's a 1-to-1 mole ratio between hydrochloric acid and the potassium hydroxide. This means it takes 1 mole of hydrochloric acid to react with 1 mole of potassium hydroxide for this reaction to actually go through. So that means that it would be exactly the same as the number of moles for the acid. So I'm going to write that in there. And once again, using the formula triangle, we can now calculate our missing value, which is our concentration, by simply doing the number of moles divided by the volume. So that's 1.35 times 10 to the power of minus 3 divided by 0.01. This gives us an answer of 0.135 moles per decimeters cubed. Now, the thing is, we need to take a look at the number of significant figures. We always take the lowest number of significant figures given the question, because we can only be accurate to that many significant figures. So, in this instance, we can only be accurate to 2 significant figures because of the 10 centimeters cubed, which was in 2 significant figures. So let's have a look at that. And we round it to 0.14 moles per decimeters cubed. And that will be our final answer. Hope that helped. See you in the next video.